Hello everyone. Today we're going to look at negative gradients. Very similar to positive gradients, we know that in year 0 we have to have our value of the gradient itself equal to 0. So if we look over here to the right, you will see this is a negative gradient, a g, a negative gradient. The problem that we have, or that we have with the one on the left, is that our 0 value is not. Our year 1 value isn't 0. Here we have our gradient g, and it's a negative gradient, but we do see in this year we do have a value of 0, which is what we want. And if you look in the front of the book, that's what it always states. That's by definition the gradient, whether it's positive or negative, that year needs to be 0. Even with uniform series ones, that has to be that way. If we look on the one here, the problem that we're given, we see we're trying to find P here, and we don't know what P is, but we see in year 1, right, in year 1, this value is not equal to 0. So how do we get this gradient, which is negative, to equal 0? Oops, sorry about that. Something happened here. Let's see if we can get back. Okay, sorry, things were switching around a little bit. Let's take a look. What we can do is we can break this out into two sections again, just like we did before with the last problem with the positive gradient. We can make this into, one would think, oops, that's Control Z then. One would think it would be a positive gradient going across here. But that doesn't really work for us. That won't work. But what we can do is we can make a positive uniform series going across here. And if we do that and subtract our gradient, that will work. Let's take a look at that. Let's do this. Let's add these two together. Let's draw our cash flow diagram. And here we have our year 0. And then we'll have year 1, and our uniform series will be 500 all the way up to year 4. Again, our value is 500. So if we look at our cash flow diagram, we know in year 0 we don't have anything. Year 1 we have a value of 500, so that's good. But in year 4, we have a value of 500 again because of this uniform series, and that is not what we want. We want to have something negative, right? So what we want to do is we want to add on a cash flow, or a gradient, a negative gradient in this case. Start out in year 0. We know is a value of 0. For some reason I gotta get this wrong pen here. This should be 0. Then in year 1 it should also be 0 and should then decrease from there to year 4. So 1, 2, 3, and 4. Okay? And this is our G, and our G is equal to, in this case, in this problem, 100, right? It's decreasing by 100 each time. It's a negative gradient. So with this information now, if we look at that, then we can look in each year. Let's kind of take a quick look at that. If we do a little table, let's do a little table, quick table. Oops, sorry, let's do that. Let's make a quick table and see if this makes sense for us, right? So we'll have year here, year, and this is dollar, how much it is, right? And in the first year, we see we have from our uniform series, the red one, in year 0, we both have 0 because we're trying to find that value. In year 1, we have 500 from the red plus 0. So that equals 500. That looks good. Year 2, we have 500 again, plus a negative 100, right? We're subtracting that gradient, so that's 400. Well, that looks good. Let's do year 3. Again, 500. Sorry about that. Minus 200. Our gradient is increasing. That gives us 300. And year 4. Let's do that one real quickly. We'll have 500 plus our negative gradient of 300 equals 200. So we see this does recreate our cash flow diagram that we really wanted. So now we know that we should be able to work on our solution and find this value of P, knowing our interest rate is 12%. So let's take a look at that. P equals, what does P equal? It equals our red portion, and our red portion is a uniform series again. Oops, sorry. Get rid of that. That's the red part, and the red part is 500. I can select the pen. 500 is our A, so let's find P given A. Our A is 500 at 12% for 4 years. Okay, plus a negative, plus, we're going to do the purple part, our gradient, a negative 100, we're subtracting, G, which is P, find P given G at 12% and 4 years. Okay, and if we look these up in the back of the book, we'll look up real quickly. G, P for G for 4 years is 4.127, and this P given A for 3 years, for 4 years is 3.037, and here we'll get P equals 500. You do this real quickly. 500 times 3.037 is 1518.50 minus, now we're going to subtract, and it's 100 times this 4.127, which is $412.70, right? And our final value will equal, P will equal $1,105.80 is our final value. Okay, so that's how negative gradients work. Okay, notice one other thing in gradients. If you look in the front of your book, there is no find f given a g. There is no future value for g. And what you could do then is you have two options. You can take your gradient to a uniform series using find a given g, or you can take your gradient to a present value and then take a next step or a second step and use your single payment method and take the p and move it to an f if you need to find a future value. So there's an extra step in there if you have to find that. So even like with this case, we could have found P or we could have found an F. We would now have to take this P and move it to an F using the single payment method, which is easy enough. Okay, so that's how negative gradients work. The other thing is realize this gradient could continue on if we wanted. It could have gone on down, down in the negative range this way. If we had let it go on, it could go down that way. That may help in one of your homework problems, but just be careful because it doesn't end up exactly right. All right. One other just side comment is, you see we've come up with all these different solutions of solving these different series, whether they're uniform series or gradients. We always have the option of solving these problems with just using our single payment method, which is find our present value given a future value. And we could do that in this case. We could have written real easily a long formula of find P in this case, and I'll just start writing out some of it, 500, right, which is a future value. Find P given F at 12% for the first year plus 400 P given F for 12% for the second year plus 300 P given F 12 for year 3 plus our final term of 200 P given F 12% for 4 years. So that's another method of doing it, but of course it's much longer. We have a lot more to look up, more chance for error when we do that. This other method of just having these two sections here are much shorter and a lot cleaner and easier to do. So that's a much better way to solve this problem than to work it out the long way. But everything we learn in Chapter 3 could be done for all types of problems. The problem is, what if this goes out for 100 years or 150 years? It makes it a little more cumbersome. Okay? So hopefully that clarifies how gradients work. Again, if you have questions on any of this, please email me and I'd be happy to help you, or actually post it on the discussion section is probably the best place so we can share it with everybody and we will work through those problems together. Thank you very much and have a great day. Bye.